Troy Swope is co-founder of Terram Lab. Welcome to EarthX, Troy.
Oh, thank you.
So, what does Terram Lab do?
That's a great question. So, on the surface, Terram Lab is a material science company, but we have a master plan, and our master plan is to take the harmful chemicals and plastic out of food packaging, and that will create an unlock where you could take food waste and packaging waste and ultimately return that to a farm. So a little illustration, quick service restaurants here in North America alone create 10 to 15 billion pounds of waste. And more than 90% of that ends in landfill. And that's, 70% of that's food waste, which releases methane, which is just a disaster for the climate. So our vision, again, is if you take the harmful chemicals in the plastic out of the packaging, you can take the packaging and that food waste together and create a really nice carbon, phosphate, nitrate rich sawdust, if you will, and return that to a farm in support of mega trends like regenerative farming, which has huge benefits for the planet. And then ultimately, if you can get rid of synthetic fertilizers, you can start cleaning up the rivers here in this country. And so our master plan, phase one, get the harmful chemicals and plastic out of packaging, and then build the infrastructure and capabilities to ultimately return that waste back to a farm in support of regenerative farming.
So let's begin by taking these chemicals out. That is not an easy thing to do, but how would you propose to do that?
Well, we look to nature, really, and you're right, it's challenging. So I think just a little education. When you get a Starbucks or you get a cold drink at McDonald's and it's paper-based, there's plastic in that.
Yes.
So all paper is a nest, right? Yeah. So when that nest stops oil and grease or stops water or liquids, to getting on your lap, there's generally a harmful chemical or there's plastic in it that gives it that performance. So we look to nature. We develop technologies, that's plant-based, methylcellulose-based technologies that give us the performance like plastic, but ultimately it goes back to the earth and it actually becomes a stimulant to the earth. And you could actually eat it. I wouldn't recommend it, but you could.
Okay, so but you basically develop a new material that can be used as the cup in
Correct.
Starbucks.
Yeah, absolutely.
So you're not recycling the Starbucks cup. That's a lost case.
No.
One that.
Well, we think that another way of thinking about circularity is giving it back to Earth, right?
Yes.
So if we can break it down into a fertilizer, and it's a plant stimulant, that's another way of being recyclable, right?
Yes.
So it's the end of life's a little bit different. Like we saw from Eden last night, it's turning waste to value.
Yes.
Right?
But the challenge always seems to be, because there are more initiatives that have at least attempted to solve this problem, is always economics. It's just more expensive.
Yeah, you're 100% right. So I started this mission 15 years ago, and just a little story on that. I worked for Intel in semiconductors. I ran a material science group, and I'm a father of 4. And we were working on a project, basically Intel single-use plastic items, and we were shipping Intel's products, very expensive products all around the world, and the plastic itself was outgassing. So outgassing is your new car smell. Yeah. It was actually contaminating Intel's products. Well, my wife comes home from the supermarket, and there's a sea of food and plastic, and I started wondering, is there plastic in the food, right? So when I started taking that food into work, which in a clean room semiconductor environment is probably not the best idea, and I was just asking to the lab, is there plastic in this food? And there is. There's an alarming amount of plastic in our food.
So to back up here, so I buy this container that has lettuce.
Yeah.
And then I think I'm eating healthy lettuce, but you tell me I'm basically eating plastic.
You're going to eat plastic. Yeah. So we know that you eat about a credit card's worth of plastic a week. Being from the Netherlands, maybe it's a half a credit card. You might be doing a little better, but...
I live in California.
Yeah,
so
you live in California, so you're eating at least a credit card's worth of
Yes.
plastic a week. And there's a New York Times article that came out just last week that says we have 5 bottle caps worth of plastic in our brain. So that's nanoplastics, and that's primary sources of where you're getting that from are your water bottles, from your Coke bottles, or from the food that is stored in plastic. But back to your economics question. So my aha moment was I was concerned my children were eating this plastic.
Yeah.
Right? And so I grabbed a team of really smart scientists from Intel and said, well, let's develop technologies that get this harmful chemical away from, and harmful chemical plastic away from our food packaging and from our children. And we set out from day one and said we're going to have to be economically feasible, right? So our mission and objective has always been this: we're not sustainable if the customer can't afford it, right? And so our technology is very comparable to plastic today, but it's taken us 15 years to get there.
But you can compete.
We compete really well.
But that is a major breakthrough.
Price and performance, by the way.
Yeah, both. That's important.
Price and
I get that.
performance.
Yes. So now, next question: how do you get that at scale in the world, right? Because I'm sure Starbucks wants to buy your cups if they know that you have them,
Yeah, so our strategy isn't necessarily to make the cup. So we are building chemistry compounding facilities all across the country, and we're currently working on the Netherlands as well, to where we can just coat existing paper. So we work with the infrastructure that's already there. There's paper mills all over the world. There's cup converters all over the world. We just coat the paper. And then ultimately, when we coat that paper, now that same cup that you see at Starbucks, it'll look and feel exactly the same way to you today, but it'll just have a healthier chemistry in the inside.
Okay, so let me understand this, because today that cup also goes through the same process, I suppose. So the cup maker gets paper, of course, from somewhere, and then from somewhere else comes that layer. Is that the way that goes?
Or often they buy that paper coated already with that coating on it, that plastic liner on it, and then they just process it, the converter processes it for them. So now they'll buy that paper with our coating on it. Okay,
so you make the connection too?
Correct.
Yeah.
Correct.
But the difference is that yours, and how does it go in the end of life? I mean, if I put it, bury it in the ground, it will compost?
Exactly, it'll compost. So our objective was, we felt that the most end-of-life options we could create, the better for the planet. So it's still recyclable, it's compostable, it's home compostable, depending on the paper substrate you put it on, but our coating certainly is. And we wanted to make sure, ultimately, if it ends in the ocean, it's marine degradable.
Yeah.
So we wanted to make sure that there was multiple end-of-life options.
Well, that's important, because and ultraviolet, meaning protecting it from light.
Correct.
Do you do that, or
no? You don't need to, right?
But that means that if I leave my cup in the window for 3 months, there's no cup.
It'll break down. Yeah.
But that's okay, of course.
That's okay. Yeah. We might need to change a little bit of our behavior, right? In America, we work with customers today that have operations in the U.S. and Europe, and they'll have shelf life in the U.S. that's 60 days and a shelf life in Europe that's 30 days.
Okay.
So if you want a packaging that gives back to the earth, it's far better for us to have a challenge of 30-day shelf life than a 60-day shelf life.
I get that. Yes. So they have challenges.
Yeah, exactly.
So you tell me that you're already building facilities to build this product. This.
Yeah, we're in the market today. We have a number of quick service restaurants, is kind of where we started, that are adopting our technology today. We are getting a little bit of a tailwind from extended producer responsibility, not only in Europe, but here in the U.S. So Oregon, California, Minnesota, Maine, and Colorado have adopted this extended producer responsibility. And I think it's on path to have the right planetary impact that we want. But certainly our technology is beneficial to them in that EPR, because we have, again, it's that extended producer responsibility, that tax, those fines are based on how many end-of-life options or how successful your end-of-life options are. Yeah.
So the material you can turn it into a cup, but also into some kind of box for food, right? It's the same thing.
Correct. Yeah, when you think about like a quick service restaurant, everything from a sandwich wrapper has an oil and grease barrier in it, to a fry container, to your cups. That's one avenue. The place I'd want you to think about where we're really active is salty snacks. You think about all your chip bags.
Yeah.
And when you think about the sea of plastic in a supermarket today, most of it's films and bags. We are an excellent replament for those.
Even for these potato chips?
For the potato chips, yeah. You're going to see us...
But is it see-through then?
No, it's not see-through. It's going to be like a paper, but you can do some really nice printing. If you look at most chip bags today, they're not see-through. Like
that's true.
Doritos, they have this beautiful picture of what the chip should look like. We could still do that. It'll look, similar, printed, but it's just paper, and it'll go back to the earth.
It's perfect, but the concept of doing this is, of course, very much circular economy. Now, but ultimately, not yet, you're not going back to the farm as you talked, but already will be good if you go to the landfill, because there at least it's degrading, right? your stuff.
Exactly. So if it ends up in a landfill today, it's better than something that won't break down in the landfill. That you'll ultimately break down. Ideally, you would want some methane capture or something like that in the landfill, but it will break down. But 35% of our waste doesn't end up in the landfill, right? It ends up in the side of the road. I don't know if you've taken a trip in New York lately, but I was driving to RFK, and it's just waste the whole way. It was quite disappointing. But if our technology ended up on the side of the road, it would be gone in, within a week. Right. Especially with weather. The weather of New York weather.
It's good. It's good.
Yeah,
for
the weather.
No,
the weather would help quite a bit. Yeah.
But and of course, the whole challenge of closing the waste stream and by bringing it back to the farm, that's a whole different thing. But your technology allows for that, but that's not your mission.
It is our mission, but it's in phases, right? It's part of the master plan. But the unlock, you couldn't even think about taking the restaurant waste and bringing it back to the farm, certainly quick service restaurant, fast casual restaurant waste, back to a farm, because the packaging was a contaminant. No farmer would want that packaging on their farm. PFAS, forever chemistries, are biodegradable, right? So it breaks down perfectly, but it leaves a horrible stain in the soil and is toxic, right? So we need to build the trust in the packaging with the farmers so that ultimately we can create that circularity. And when we start getting to that great unlock, right? So that really where we're using that restaurant waste back onto a farm in support of regenerative farming, I can't imagine a bigger planetary impact.
No.
And we believe we are the most environmentally friendly company on the planet, and our impacts will speak for itself.
So you have a shirt that says you are enough, and I will add to that you're more than enough with that. But I will ask you a somewhat critical question. So why didn't you start this sooner? I mean, why Intel?
I wasn't smart enough to start it. I needed Intel surrounded me with brilliant people. I was in Intel in the late '90s, early 2000s, and I was just completely surrounded by brilliance every day. In fact, Intel had so many smart people they didn't know what to do with them, and so they all left, I think. So, but it was an unbelievable education, and that education, I've had since gone to school and got sustainability degrees from ASU, et cetera. But Intel was the most amazing education.
So without Intel, there wouldn't have been Terram Lab.
I wouldn't know how to fail. I wouldn't know how to design experiments, evaluate experiments, and I wouldn't know how to fail without Intel.
How important is failing then?
Oh, failing's absolutely important. You just got to fail fast. And failing fast means you're learning from the failure. You can't afford to fail and not learn from it. Because if you repeat the same mistakes over and over again, you're in trouble. But when it comes to innovation, you need to fail quickly. You need to learn from it. So you need to know how to design experiments, analyze experiments, fail, and it's okay to fail. It's okay because that's just part of learning. And I think the other thing that's really important when we think about the planet and what we're all trying to do here is that we need to remain optimistic. Right. We've solved some major problems before. We remember acid rain. Right. We solved acid rain. So, and there's many other examples, but we need to remain optimistic. We can do this, and as long as we believe that we can do this and we should do this, then we'll get it done.
So you humbly say we are the most important environmental company in the world, which
was that humble?
It's very humble, and that's good to say. I love that. No, ambition is good, but the point is, how quickly can you scale this? I mean, you need to put this everywhere.
We think we're, with the tailwinds that we see from legislation and consumer demand, we think selling chemistry, we can do it pretty quickly. We originally set out we were going to develop the full packaging solution, but I think the best thing for the planet and for our customers is to use that existing infrastructure of paper-based packaging and provide the key ingredient in that technology that will unlock, again, that performance that we need and really that scale, right?
So why do you do this?
My kids, 100%. Yeah, my kids. I think we're all probably here for some sort of reason, thinking about the future. I remember when I started this journey focused on the planet and planet technologies is going to a number of places. I grew up in California, and taking my children back to California and looking at the beach and trying to describe to them what it used to look like, without the pollution, and it was depressing, and I was going, how long are we going to tell our children what it used to look like? And then just the chronic disease, with children today, especially here in America, it's shocking, and somebody's going to have to do something about it. So I think for us, step one is getting those harmful chemicals and that are in plastic, and there's other harmful chemicals in packaging, away from food, away from our children. And then if you do that and you do it right, then you have something that will give back to the planet, then you won't see it floating in rivers and in oceans. I think it's a bit ridiculous that in America, our two biggest rivers, Mississippi River and Missouri River, the EPA says don't eat the fish and don't swim in it. Yeah. And we talk about China and all that stuff. We should not look at anybody else until we clean our own river. And I don't like the ambiguity of climate change, that discussion of climate. No, focus on pollution.
Clean water,
clean
the
river.
Air. Yes.
Clean the river.
Understood.
And then almost all the visible pollution is plastic. But what's kind of ironic to me is we renamed the Gulf of Mexico to Gulf of America. Why? Yeah. It's primarily a dead zone. Yeah. It's a dead. Yeah. Maybe we should clean it up before we name it.
Yeah,
right?
I like it. I like it. So you had that moment in the Intel lab where you saw the problem, that it actually what you feared was true, that the plastic was in the food. Then you thought, okay, we need to do something. You started developing. So was there a big moment that you thought, now we've done it? Can you tell me how that was?
Yeah, I had some,
because there was a lot of failing involved.
Really smart business partners. Yeah, a lot of failing, and you got to accept a little bit of it may not be the ultimate planetary solution, but it's getting better. You're making progress. What really helped us recently is I met this group that was in Alabama that was in the pharmaceutical, and it really, innovation comes from everywhere, right? Uh-huh. They were in the pharmaceutical space, and we ended up acquiring them, and they joined our team. We've been working with them for over a couple years, but we finished acquiring them in December, and that was a real unlock. The combination of their technology and our technology and customer experience came together, and that was a real aha moment. But to your point earlier, there was a number of times where we failed, just constantly failed. And that's where optimism comes in. You just got to believe you'll get there, and that belief in that you're learning and belief in the process.
And that moment that you were there, what was that moment like?
I don't think I'll ever feel, if anybody knows me, my team will tell you, I'll never feel like I'm there, right? So
you are enough.
I'm enough. I know. I got it. This is for me, not for you. Right? So I got to read that. I don't feel like we're ever quite there. I'm a bit of a perfectionist that way, but I do believe we will solve some major challenges and we'll create the right partnerships that will get this thing to scale, and we'll see some major improvements in pollution and the oceans and first of all, human health, our children's health. I think that's phase one.
What's the best thing that has happened to you so far?
One of my sons. I have 4 children, 3 boys, and one of my sons works with me now. So that's pretty amazing.
Thank you, Troy.
Thank you.